Good afternoon, friends, and welcome again to another session of mathematics. Today we will be dealing with a very important topic, that is matrices. So today we will be starting matrices and we will be discussing the matrices chapter. It's a very important chapter of class 12. Okay, so what we will do is that we will cover up all the parts of the matrices in the whole session, and then I will be dealing with some very good numericals in this session. So please be alert and please keep following my class. So let's get started to Parijat sir classes. As you all know, this is Parijat sir classes. Okay, so let us get started with this, friends. And before starting, once more I would like to request you, please like, share and subscribe. Like, share and subscribe my channel. Okay, so let's get started without wasting any time. So matrices, as you can see here, I have discussed the thing in a very simple manner. So this is how a matrix will look. Okay, it will have, this is called the column. Okay, so this part is called the column. This is the column. So column 1, column 2, column 3, and this will be called as the row 1, row 2, row 3. Okay, so as you can see, this element will be called as the first row, first column. So always it is the row first, it is the row and then the column. So it is the first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, and third row, third column. Okay, so this is how we will be dealing with the matrix. So now let us see how many types of matrices are there. Type 1, row matrix. So if you have only one row, we will call it a row matrix. Similarly, if you have only one column, it will be called as a column matrix. Square matrix, that means, see, number of rows. How many rows are there? So there are 3 rows and 3 columns. So if the rows and columns are same, it will be called as a square matrix. Next, diagonal matrix. So if the elements if we have the elements only in the diagonal part, you see, this is the diagonal elements and others are 0. Okay, others are 0. If the elements are present only in the diagonal and other elements are 0, it is called as the diagonal matrix. So let's move forward. So now we are dealing with another type, that is the scalar matrix. So see, if a matrix has a number, if it's a scalar matrix, means a matrix which has a same number in the diagonal, that is called the scalar matrix. Okay, it can be any number. Next is identity matrix. If that number is 1, it is called identity matrix. If that number is 1 in the diagonal, so that will be called as an identity matrix. Please see, it is a 3 by 3 matrix, it is a 2 by 2 matrix. So along the diagonal, if you have only 1, it is called the identity matrix. Next, null matrix. See, all the elements of this matrix should be 0. That's called the null matrix. So let's move ahead. First topic we will be doing is equality of matrices. Okay, so see, this is one matrix. It is 2 by 2 matrix. It is a 2 by 2 matrix, 2 rows and 2 columns, 2 rows and 2 columns. It is a 2 by 2 matrix. So this is equal to another 2 by 2 matrix. It is equal to another 2 by 2 matrix. So find x and y. So find x, 1, y. Now since these two matrices are same, so we will be telling that because these two matrices are same, so we can tell this element should be equal to this element. The positional elements will be same. Similarly, we can also tell that this element should be equal to this element. Similarly, we can tell that this element should be equal to this element, and we can also tell that this element should be equal to this element because it is an equal matrix. Okay, so now taking this, so 2x plus 1 equal to x plus 3 is, we can find x. Similarly, 3y is equal to y square plus 2, so we can factorize it and we can find the value of y easily. So this is how you can find the unknown values if you know that it is an equal matrix. It is an equal matrix, so you can equal their positions. You can equal the positions and find out the unknown things. Next, let us move ahead. Another one, see, we have taken, it is a 3 column, first column, second column, third column, and it is the first row and the second row. Okay, so it is a 2 by 3 matrix. It is a 2 by 3 matrix, 2 rows and 3 columns. Similarly, this is also a 2 by 3 matrix. So we can tell here that this element will be equal to this element. So this is our first equation. Similarly, we can tell that this element is equal to this element. So we get two equations, and when we add the equations, the y cut out. Okay, so we get the x. Putting the value of x in any part, we can get the value of y. Similarly, we can also tell that this element should be equal to this element, and this element should be equal to this element. So we again make two more equations, which is this. Solving them, we get a as 0 and b as 5. So this is how we solve the equations, by equaling the matrices. Clear? By equaling the matrices. Let's move ahead, friends. I would suggest you please pause my video and keep noting how I am discussing the things, so that you will be able to understand in a very clear manner. You keep pausing it, keep doing it along with me, so then you will understand in a very easy manner. Okay, just don't watch it, but please keep doing along with me. So next, let's move ahead. So this is a matrix, as you can see. This is a matrix A given and a matrix B given. So we want to add A plus B. So what we will do, if we add A plus B, we have to add the same positions. This is added with this, so that is, you can see 1 with 6, 2 will be added with 5, 3 will be added with 4, 4 will be added with 3, 5 will be added with 2, and 6 will be added with 1. So this is how we get the matrix. This is how. So if we subtract also, then we can do this in the same format. Clear? Next, let's move ahead to another topic, that is commutative law. What is commutative law? What is commutative law? So friends, let's see what is commutative law. Commutative law. So commutative law says that if two matrices are added in this way and they are added in this way, the result will be same. If two matrices are added in this way and then they are added in this way, then the answer will be same. Second, let us see What is associative law? What is associative law? So associative law tells that first if I add A plus B, with that answer if I add C, A and B, A, B, C are three matrices. Please note it. These are three matrices. These are three matrices. So first if I add A and B, with that result of the matrix if I add C, the answer will be same as first if I add B plus C, and then with that if I add A, the answer will be same. Okay. Next, let us find out if A plus B is equal to B plus C, then we can say, if A plus B is equal to B plus C, then we can say that we can cut B and B and we can tell A is equal to C. We can cut B and B and we can tell that matrix A will be equal to matrix C. Clear? Next, move ahead to another part, friends, that is multiplication of matrices. Let's see multiplication of matrices by a scalar. So see here what we are doing. This is a matrix, and if I want to multiply it, this is a matrix. If I want to multiply it with a number, scalar number, that means all the numbers, all the elements get multiplied with the same number. All the elements get multiplied with the same number. So if this is called multiplication by a scalar. Scalar means a number. Here we have taken as half. So if I multiply a matrix with a scalar number, that means all the elements will get multiplied with the same number. Clear? Now let us start simplifying one by one. Simplify. So this is the first question. Let us deal with this. That is, see, cos theta is cos theta sin theta minus sin. This is the thing given. So let us simplify. Now this is in multiplied form with this matrix. That means all the elements will get multiplied with the outer number. So this becomes cos square theta. This becomes cos theta sin theta. This becomes minus cos theta sin theta, and this becomes cos square theta. Multiply all of them with cos theta. Similarly, multiply all of these with sin theta. So it becomes sin square theta minus sin theta cos theta, sin theta cos theta, and sin square theta. Now the symbol given is plus, so we have to add. So what we can add? We have to add the similar positions. That means we have to add cos square theta with sin square theta. Then we will be adding cos theta sin theta with this minus cos theta sin theta. Then we will be adding minus cos theta sin theta with sin theta cos theta. Same positions we will keep adding, and then we will add is cos square theta with sin square theta. So let us see how it looks. So it looks like this. Now sin square theta plus cos square theta is 1. Sin square theta plus cos square theta is 1, and this will be cutting out 0. So we get this as the answer. Clear? Now see, friends, another sum is given here. There is a matrix A such that there is a matrix A. So see, condition is given. What condition is given? The condition given, see the matrix A, the condition is given 2A minus 3B plus 5C is 0. This is the condition given. You have to find the matrix A. So B is given to us, B is given to us, C is given to us. So what we have to do, see, we have to put it in this equation. So 2A, 3B, that means all the elements of B will be multiplied with 3. 3B plus 5A equal to null matrix. So this is 3b. All elements get multiplied with 3. All elements get multiplied with 3. All elements get multiplied with 5. And these, now we will add these two. So see how to write it. It is, what we are doing is, since there is a minus, we are multiplying with minus. This minus we are multiplying, so this becomes plus, minus, 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 and this becomes plus. We have multiplied with this minus, we have multiplied with this minus, and now we will add these two matrices. We will add these two matrices. Okay, so when we add the two matrices, now the result becomes this. See, we are adding the same elements, same position elements we are adding. So the result becomes this. Now 2a, so this minus this, now we will subtract these two. So 0 minus 16. So we are subtracting the same positions. We are subtracting the same positions, and we are getting these values. We are getting these values. So what is a? Now a will be every value divided by 2. So these are the final answers. So this is our matrix A. This is our matrix A, which we are supposed to find. Clear? So friends, let's see the next one. That is, let's see what is the next one. The next one says multiplication of matrices. Okay, so we will be dealing with multiplication of matrices. We will deal with multiplication of matrices. Okay, so please note it very carefully, because this is a very important topic. This is a matrix A, this is a matrix B. I want to multiply A and B. Please note how to multiply this. See, the first step is given here. This is our first step, and this is our first step. That means every element of the first row is multiplied with the first column. So that is why, see how to write 1 into 2 plus minus 2 into minus 1 plus 3 into 4. So this is how I have written. Okay, next, the second column, this second row is multiplied with the second column. So see how I have written. So first what you have to do is that you have to first complete the first row. Here the first row gets multiplied with this, then the first row will get multiplied with this, as you can see. So 1, I'm showing it here, 1 into 3 plus minus 2 into 2 plus 3 into minus 5. Clear? So this is how we write it. Next, what we are doing is, let me show it to you properly. Okay, so now what we will do is we will multiply the second row first with the first column. So 3 into 2 here plus 2 into minus 1 plus minus 1 into 4. So this is how I have written. Okay, and next we will do, next what we want to do is, okay, so let us first erase it. Okay, now we want to do it is 3 into, this was 3. Okay, so 3 into 3, then 2 into 2, and then minus 1 into minus 5. Okay, this is what we will be doing it. So please note. So first let me make it clear. Okay, so this is how we multiply, and then we will write the results here, whatever we are getting, and that is the result of the multiplication of the product A into B. This is how we multiply. Clear? So please watch carefully, please watch very slowly how I am explaining it. Again and again I am telling, please pause the video and understand the steps how to multiply the things slowly. Next, let us know certain theorems of this. That is, the first theorem says that I into A, I is the identity matrix. If you multiply any identity matrix with a matrix, you will always get the same matrix. So if you multiply I into A or A into I, the result is same. The result will be the same. If you multiply I into A or A into I, the result you will get always the same matrix. Second, they are telling that if, second theorem says that if you multiply a matrix with a null matrix, okay, so I have already shown you what is a null matrix. Let me again show it to you. Null matrix, if possible. So this is our null matrix. As you can see, all elements are 0. This is our null matrix. So now let us return back. So if you multiply any matrix, with a null matrix, the result is always a null matrix. Clear? Next theorem says that if matrix A satisfies the polynomial, see, if you tell that there is a matrix A which is a solution of this equation, so how to write it? Please note how to write it. It will be in place of X, you will keep putting the matrix A, because A is a solution of this matrix. A is a solution of this matrix. So we have to, in place of X, we have to put the matrix A, and we can write it like this. Clear? Now please remember here there is, in this part you have to write it as 2i, because you have to satisfy with the matrix. Here we will replace it by A, here we will replace it by A, and here you will replace this 1 with the help of the identity matrix equal to the null matrix. Mind it, this is not 0, this is a null matrix. Clear? So let's move ahead. So okay friends, so let's see the question. First question, what it is telling: if A equal to 0 1 minus 1 0, find x and y such that xi plus ya square equal to A. This is given. So this is xi, means x is multiplied with the identity matrix. What is the identity matrix here? 1 0 0 1. So if you multiply this with x, it becomes this. Similarly, ya, if you multiply the matrix A with y, you will get this. Now we have to add it first. So that means x plus 0 is x, 0 plus y will be y, 0 plus minus y is minus y, and x plus 0 is x. And now we have to square it. That means we have to multiply it 2 times. So this is how we write the matrix. You see, this is how we write the matrix, and I told you how to multiply. I told you how to multiply it. So see, first we will take this row. First we will take this row, and then we'll multiply with this. Okay, so what we should get, let's highlight it first with some different color. Okay, so we will do x into x plus y into minus y. Okay, x, so how much we get? So see, this is how we get. Similarly, now we will do 1 minute, friends. Okay, so now we will do x into y with y into x, and we will get this result. Yes, so we have got this, we have got this. And next, one minute. Okay, friends, 1 minute, just wait, let me make it a little bit clear. Okay, so now we will do is minus y into x plus x into minus y, and then we will get this result. And similarly, okay, so now what we will do is minus y into x minus y into y plus x into x. Okay, and we will get this result. Clear? Which is equal to 0 minus 1. It was given already. It was given, it is 0 minus 1 minus 1 comma 0. So now when we get this, now what we will do, it is given already that it is an equal matrix. It is already given. See, it is an equal matrix. That means now we will be equaling this with this, and this is 2xy with this. So we are doing this. See, from here x equal to minus 1, x equal to 1 by 2y, we will put it here in place of x, and then we will calculate why we are getting this value. We are solving it and we are getting y this value. Now we will put the y back here, we will put the y here, and we will get the x. So this is our solution. This is how we solve this part. Clear? Next, let us move on to the next type, that is, see, A given, matrix A is given, matrix I is given. Find K such that A square equal to 8A plus Ki. This is the condition given. A square equal to 8A plus Ki. So first we have to calculate A square. So this is A into A, as I told you. How we will do? First we will do 1 into 1 plus 0 into minus 1. So here we have written. Clear? And then we will do 1 into 0 plus 0 into 7. Here we have written. So now let us see the next one. Now we will do minus 1 into 1 plus 7 into minus 1. Okay, So here we have written this, and now we will do -1 into 0 plus 7 into 7, and here we have written this. So now solving these we get the answer as this. We have solved this, and these are the results. Now we will do 8a. That means all the elements of A multiplied with 8, we get this. Now we will do ki. That means all the elements of identity matrix get multiplied with k, we will get this. And now we put it in this equation, that is a square equal to 8a. This is a square, 8a plus ki. Now we will add these two matrices. So 8 plus k, 0 plus 0, minus 8 plus 0, and 56 plus k. So these two matrices are equal, and now what we will do is that we will equate. We will equate on both sides. That is, now we will do, that is 8 plus k is equal to 1. Same positions we will equate, and we will get the value of k. Clear? We'll get the value of k. This is how we will be doing it. Next, let's see friends, what is there. If A equal to this matrix given and fx is given as this is the fx equation given, show that fa is 0, show that fa is a null matrix, so that fa is a null matrix. So let's see. Fa means, we will write like this. Fa means it will become a square. In place of x square, it will become a square. Minus 4x will become 4a, and 7 will become 7i. So this is a square. So see, let's calculate a square. A square. So a into a. So how we are calculating it? 2 into 2 plus 3 into minus 1. So here we have done, that is 2 into 2, 4 minus 3. Clear? So now let us first erase it. And now what we are doing? 2 into 3, which is 6, plus 3 into 2, which is 6. So here we have done. Next, what we will do? Minus 1 into 2 plus 2 into minus 1. Now we will do minus 1 into 3 plus 2 into 3. 2 into 2. Okay, so now we are getting this result, that is 1, 12, minus 4 and 1. Okay, so this is a square. Now 4a will be 4 multiplied with the matrix A, which we will get this, and 7i will be this, because I is 1001 multiplied by 7 becomes 7007. Now let us put it in this. So this was a square, this is the a square part, this is the minus 4a part, and this is the 7i. So what we will now do here is, we have to add the same type. That means I will do 1 minus 8 plus 7, which is this. Then we will do 12 minus 12 plus 0, which is this. Then we will do minus 4, it will become plus 4 plus 0, which is this. Then we will do 1 minus 8 plus 7, which is becoming this. Okay. So when we calculate it, the answer becomes 0. That means we have proved it that FA is a null matrix. Clear? Now they are telling that use this result to find the value of a to the power 5. Now please watch it. Use this result that FA is 0. FA is a null matrix. Use this result to find the value of a to the power 5. So how to do it? So see, we know a square minus 4a plus 7i is 0. So what is a square? 4a minus 7i. Please keep this in mind that a square is, this is our a square, so keep it in mind, a square. Now watch. If I want to find a cube, what will I do? A square into a. And as I told you, this is my a square. That into a. So what it has become? 4a square minus 7a. 4a square minus 7a. Correct? And again, as I will show you, in place of a square, so again we have put 4a minus 7i. So it becomes 16a minus 28i minus 7a. So it becomes 9a minus 28i. So this is my a cube. Clear? Next, a4. So how do you find a4? a4 is a cube into a. And we are now putting the value of a cube. This is our a cube. See, this is our a cube into a. So 9a square minus 28a. Now in place of this a square, again we will put 4a minus 7i. And we are calculating it. We are getting this. Now we have to find out what is our a5. So this is how to do a5. This is a5, a4 into a. This is my a4. This is my a4 into a. And now instead of a square we are putting this value. So it is this 32a minus 56i. So it becomes this. Now we have come that a5 is actually this. Now what we are doing is we are putting the value of a here. In place of a we will put the matrix A, and in place of I we will put the matrix I, and then we can calculate it. Then we will be calculating it. And so friends, so now see, here is the matrix A5 will now be calculated this, and we get this is the A5. Clear? So next, see, 1 minute friends. Okay, so now we are dealing with this a numerical part. So let's see, there are two families A and B. So A and B are two families. There are two families A and B. Okay, there are 4 men, 6 women, 2 children in family A, and 2 men, 2 women, 4 children in family B. Okay, so see, this is the family A, and men, women and children 4, 6, 2, and this is the family B, 2, 2, 4. Now the requirements of the calorie. So see, calorie requirements are given here, that for men it is 2400, for women 1900, for children 1800. So this we can, this is the calorie requirement of the men, women, children. Similarly, the protein requirement are also given for men, women and children. So here we have shown the protein requirement. Now they are telling what is the total calorie and protein. So we have to multiply these two. We have to multiply these two matrices. So here we are multiplying. Okay, as I told you how to multiply, already I have shown you. So first we will take what? 2 into 2400 plus 6 into 1900 plus 2 into 1800, and this we will get this. Similarly, now we will do 2 into 55 plus 6 into 45 plus 2 into 33, and we will get this. Okay, and now what we will do? We will do 2 into 2400 plus 1 into 1900 plus 4 into 1800, and we will get this. Similarly, now we will do 2 into 55 plus 1 into 45 plus 4 into 33, and we will get this. Clear? So this is our total requirement of the calories and the protein by the two family. Okay, so this is the calorie requirement of family A and B, and this is the protein requirement of family A and B. Clear? Let's move on to the next sum and see what is there. Now we have to deal a very important topic, that is called a transpose of matrix. Very important topic this is. Transpose. So a to the power t means we are doing the transpose. So what is transpose? Transpose is the interchanging of the, transpose will be the interchanging of the row and column. That means the row will become the column and the column will become the row. That is called transpose. For example, see here, this is a matrix, so this row will become the column. First row will become the first column, second row will become the second column. This is the transpose. So this is how we do the transpose. Clear? So let's see few theorems which are very important for us. If you do transpose of a transpose, you will get the original matrix. Similarly, A plus B transpose means A transpose plus B transpose. Similarly, Ka transpose, K is a scalar quantity, so how to write K A transpose, K A transpose. Similarly, if we are dealing with this, that AB transpose is a very important thing, mind it, is actually B transpose into A transpose. Okay, it is not A transpose into B transpose, it will be B transpose into A transpose. Clear? So let's move ahead knowing this. A equal to cos theta minus sin theta by sin theta and cos theta. Find theta if A transpose plus A is equal to I. This is our given. This is our thing given. A transpose plus A is equal to I. So what is A transpose? The first row will become the first column. The second row will become the second column. Okay, this is what we have to show in the transpose. So this is the A transpose. Now they are telling A transpose plus A, so this is the A transpose and this is the A. So we will add cos theta plus cos theta, that is 2 cos theta. Sin theta minus sin theta, which is 0. Minus sin theta plus sin theta is 0. Cos theta plus cos theta is 2 cos theta, which is equal to this given already. That means I can write 2 cos theta is equal to 1. So cos theta is equal to half. So cos theta half, please note this solution. You have to know trigonometric equations of class 11, how this solution has come. Please refer to the trigonometric equations. If cos theta equal to half, we know cos theta equal to half, so theta is pi by 3, and this is how we write the solution: 2n plus 1, 2n pi plus minus pi by 3. Next is find x, y, z if a equal to given this, and a to the power a transpose into a is equal to I. This is the condition given. A transpose 1 minute. This is the condition given. Okay, to solve this, so let's see A transpose. So how to solve A transpose? We have to interchange the row and column. The first row will become the first column, the second row will become the second column, the third row will become the third column. This is the transpose we found. Okay, now we have to multiply the A transpose and A. So we are writing, this is A transpose, this is the A transpose, and this is the A. So how to multiply? So first we will do 0 into 0 plus x into x plus x into x. So we are getting this. Okay, next we will do 0 into 2y plus x into y plus x into minus y, and we will get this. Next we will do 0 into z plus x into minus z plus x into z, and we will get this. Clear? And now for the second row we will do 2y into 0 plus y into x plus minus y into x, and we will get this. Now we will do 2y into 2y plus y into y plus minus y into minus y, and we will get this part. Now we will do 2y into z plus y into minus z plus minus y into z, and we will get this part. And now for the third row we will do, let us take a different color. Okay, so we will do z into 0 plus minus z into x plus z into x, and we will get this part. Clear? We will get this part. And now we have to do, let us clear. So now we will do z into 2y, second row with second column, a third row with the second column, minus z into y, and then z into minus y, and we will get this part. Okay, so now we will do z into z plus minus z into minus z plus z into z, and we will get this part. So now, so it is 2x square. So if I add each and every part, so 2, this is 2x square, this is 0, this is 0, this is 0, this is 6y square, this is 0, this is 0, this is 0, and this is 3z square. So we got this A transpose into A, we got this. Clear? And they are telling it is equal to I. It is equal to I. So we can tell from here that 2x square is equal to 1. And solving it, we get the value of x. Similarly, we can tell 6y square is equal to 1. And we will get y value as this. Similarly, we can tell 3z square is equal to 1. And we will get the value of z. So this is how we solve this. Clear? Next, friends, another very important topic we are now going to deal, which is symmetric matrix. We will deal the word symmetric matrix. Okay, so what is symmetric matrix? A is a symmetric matrix. This is very, very important condition. If A transpose, after doing transpose also, if you get the same matrix, that means the matrix will be called as a symmetric matrix. Clear? Suppose A is this matrix. Now transpose means I will change the first row into the first column, second row into the second column, third row into the third column. And when we do this, please note, it is actually the original matrix we have already got. It is the original matrix we have already got. That means this is actually A only. This is actually A only. So after doing the transpose, we are getting the original matrix. So means A transpose is coming equal to A. So we can tell A is a symmetric matrix. A is a symmetric matrix. A will be a symmetric matrix. Next, skew symmetric matrix. Skew symmetric matrix. So what is a skew symmetric matrix? So watch it. Skew symmetric matrix. If after doing the transpose of a matrix, I see that it is coming the original matrix but a minus sign. After doing transpose, if I see that I am getting the original matrix but a minus sign is there, so we can tell that A will be a skew symmetric matrix. So let's take an example here. So see, this is the matrix A. This is the matrix A. Okay. If I do the transpose of this matrix, so let us do the transpose of this matrix. So the first row will become the first column, 0, 2, minus 3. Second row will become the second column, minus 2, 0, 5. Third row will become the third column, 3, minus 5 and 0. Now if I take a minus sign outside, what will the elements become? 0, 2, minus 3, minus 2, 0, 5, 3, minus 5, 0. And isn't it minus of A? Yes, it is minus of A. It is a minus of A. Here is a minus sign. So that means on doing the transpose, we got the original matrix but there is a minus sign. So we can tell that A is a skew symmetric matrix. A is a skew symmetric matrix. So let's prove some few things about skew symmetric matrix. Prove that A plus A transpose will be a skew symmetric matrix, will be a symmetric matrix. So let's see. Let us do the transpose of this. Now we have already dealt with the transpose parts. So let's see here. 1 minute, friends. This we have seen that A plus B transpose is actually A transpose plus B transpose. Okay, we have seen this. A plus B transpose is actually A transpose plus B transpose. So now let us go to our sum and see. Okay, so this is a sum. That means if I take A plus B, so watch here, isn't it looking A plus B transpose? So I will write A transpose plus B transpose. This is my B transpose, and transpose to the transpose is the original matrix. Already we have done that. See, transpose to the transpose, as you can see it here, transpose to the transpose will give you the original matrix. Clear? So if I apply here, so this is giving me the original transpose, original matrix. That means this is A transpose. That means if I have taken this as X, so I have done the transpose of X. I have done the transpose of X, and transpose of X is giving me what? The X itself. That means the transpose of this matrix has given the same matrix. That means I can tell that this is a symmetric matrix. This is a symmetric matrix. Transpose of this whole matrix, transpose of this whole matrix has given me the same matrix, has given me the same matrix. Clear? So okay, so now let's see the next sum. Please watch here. Prove that A minus A transpose is a skew symmetric matrix. So let us do the transpose of this matrix. Transpose of this matrix. So it is looking like A minus B transpose, means A transpose minus B transpose. So see, A transpose minus B, this is the B transpose. So transpose will give you the original matrix. Now can I write it like this? So isn't it the same matrix but a minus sign in front? That means when I have done the transpose of this matrix, I am getting the same matrix but there is a minus sign. So I can tell that this is a skew symmetric matrix. This is a skew symmetric matrix. Clear? Next, prove that A transpose, A into A transpose and A transpose into A are symmetric matrix. You have to show that. So let us do the thing, that is, okay, so we are doing the transpose of this matrix, first matrix. So isn't it looking like A into B transpose? And we already know that A into B transpose is actually B transpose into A transpose. So we are doing, this is the B, okay, so this is the B transpose into A transpose. We are doing that. Okay, so here we are doing B transpose into A transpose. I think there's a little bit mistake here, so let us correct it here only. Okay, so let us do, so it will be B transpose into A transpose. Now transpose to the transpose, so this also we have to rub and write it in a proper way. Okay, that means this will become A and this will become A transpose. So basically we see that we are getting the same thing. So if we are transposing this matrix, we are getting the same matrix. That means I can tell this and this will be symmetric matrix. That was the condition for symmetric matrix. That condition for symmetric matrix is that if on transposing a matrix you get the same matrix, they are symmetric matrix. A will be the symmetric matrix. Next, prove that every square matrix can be expressed sum of symmetric and skew symmetric. Okay, that means they are telling that prove that any matrix is actually the sum of the symmetric and skew symmetric. This we have to show. Okay, so let us write a matrix A in this form: half A plus A to the power A transpose plus half A minus A transpose. See, half A transpose and minus half A transpose will cut. Half A plus half A will give you A. So we can write A in this format because half A transpose will anyhow cut out, and then half A plus half A will actually be A. So let us name the first part as P. Let us name the first part as P. Let us name the first matrix as P, and let us name the second matrix as Q. Let us name the second matrix as Q. Okay, so now what we are doing? We are doing the transpose of the first matrix. So it is the formula A plus B transpose, which is A transpose plus B transpose, and transpose to the power transpose, transpose to the power transpose will give you what? A. So this is the thing. So when I did the transpose of P, I am getting the P only. That means this P was a symmetric matrix. P was a symmetric matrix. Clear? Now let us do the transpose of Q. So here is Q to the transpose. So it becomes A transpose minus A transpose to the transpose. This is A. So this I can write it by taking minus common. And now this is coming minus Q. So transpose of Q is giving you minus Q. That means Q is a skew symmetric matrix. That means I wrote A as P plus Q, and I proved that P was symmetric. I proved that P was symmetric and Q was skew symmetric. That means we can tell that any matrix can be written as a sum of symmetric and skew symmetric. Clear? Next, show that the matrix this is the matrix, is a symmetric or skew symmetric. It will be symmetric if A is symmetric. It will become symmetric if A is symmetric. It will become skew symmetric if A is a skew symmetric matrix. This we have to prove it. Okay, so there are basically two cases coming out. Case 1, what is case 1? If A is symmetric, so we can write this: if A is symmetric. Now let us do the transpose of this matrix. Isn't it looking as A into B transpose? We know that A into B transpose is what? B transpose into A transpose. So here, so this is the B transpose into A transpose we are doing. Now again this can be written as B transpose into A transpose, and this is transpose to the transpose, it becomes B. So here we are getting B transpose. A transpose was actually how much? A. So instead of A transpose, I am taking as A. So see, if I do the transpose of this, I am getting the same matrix. That means this will be a symmetric matrix if A was taken as symmetric. Clear? The same matrix we are getting on doing the transpose of this, we are getting the same matrix. That means this matrix is actually symmetric if A was taken symmetric. Second case, if A is taken skew symmetric, then we can write like this. If A is a skew symmetric, we can take like this. So let us now do the transpose of this. Again, same, applying the formulas, we are getting this. Now A transpose is actually minus A, so we are getting this. So see, the transpose of this is giving the same matrix, but there is a minus here. That means this is a skew symmetric matrix if A was skew symmetric. Clear? So now let us do this. Express A, this is a matrix given, as the sum of symmetric and skew symmetric. So we all know that any matrix can be written as the sum of symmetric and skew symmetric. Symmetric, as I already showed you, it was P plus Q, and P was written like this, symmetric, and Q was written like this, skew symmetric. So see, half, this is the A plus transpose of A. Transpose means the row and column will be interchanged. So now add these two matrices, the same positions will be added. So we are getting this half, and this is a skew symmetric matrix. Skew symmetric matrix is written like this. So we will keep subtracting the first from the second, and we are getting this, and there is a half here. So taking the half common, so we will add these two matrices, okay, and that is the answer. So this is the symmetric part and this is the skew symmetric part. That means this matrix can be written like this, symmetric and skew symmetric. Okay, so with this, friends, we have come to the end of the matrices, the first part. It is basically, we have finished the matrices, the first part, and I hope you have understood it. Please go through it very nicely, and very keep pausing the video, and please try to understand each and every concept very carefully. Then only you will be able to understand. Okay, so it is my request to go through it by pausing the video and doing the sum along with me, and listening very carefully what explanations I am giving for each and every part. And I hope you have understood this, and if you have any doubts, please comment in my comment section so that I can help you out. Clear? So please keep watching Parijat sir classes, and as it is a request again from my side, keep watching Parijat sir classes, and please share and subscribe, like, share and subscribe the channel so that I can make more and more videos for you. Okay, so till then, it's goodbye from my side till we meet for another class. For mathematics, I will be uploading the second part of the matrix equation solutions. We will be uploading it very soon, so keep following it. Thank you so much.